It's pretty wild how one tiny mistake can blow the doors wide open on the secret blueprint of a cutting-edge AI. But that is exactly what happened to Anthropic, the company behind Claude. It all started with one misplaced file, a 57-megabyte source map. Think of it like a developer's own roadmap to their code. And just like that, the entire world got a peek under the hood. So let's dive into this digital detective story.
This quote right here is our central clue. It came from a developer digging through the leaked code, and it points to a piece of evidence so unbelievably bad, so complex, it became the heart of this entire story. So, what could possibly be so terrible? Well, let's find out.
The biggest stories often have the smallest beginnings, and in the high-stakes world of AI, this wasn't some sophisticated hack or a disgruntled employee. Nope, it was a simple, everyday technical error during a routine software update that kicked this whole thing off.
And the dominoes fell fast, like incredibly fast. It all starts on March 31st, when Anthropic accidentally pushes out this debug file. Just hours later, a researcher spots it and posts it online. Less than a day after that, that single post has over 22 million views. The code was literally everywhere. And when you have that many eyes on something, it doesn't take long for people to find problems. A huge one, in fact. A critical security vulnerability hiding right there in plain sight. Okay, so once the digital dust settled a bit, what did this global community of developers actually find? What kind of secrets were inside this accidental treasure chest?
Well, they found this. Over 500,000 lines of TypeScript code. The entire operational engine for Claude Code, that's Anthropic's AI coding assistant, was suddenly out there for everyone to see.
Now, this is a really important distinction. The leak wasn't the AI's brain itself. It was more like the incredibly complex machinery around the AI. Imagine getting the complete architectural plans for a factory, but not the secret formula for the stuff they make inside. It laid bare all the key engineering decisions Anthropic had made.
And that's a crucial point for Anthropic. The really core secrets, the model weights that actually make Claude, they were safe. No training data, no customer info, no API keys got out. So for the company, it was incredibly embarrassing for sure, but it wasn't a total catastrophe.
Now you think, with 500,000 lines of code to go through, the story would be complicated. But the developer community has a knack for this stuff, and they quickly zeroed in on one single, unbelievable piece of code, our main suspect. It was called print.ts, a really simple, harmless-sounding name for what turned out to be an absolute monster. And this one function, it tells us so much about the pressures of building AI at this scale. Let's start with this number, 3,100. That's how many lines of code were in that single function. To put that in perspective, that's longer than many entire small applications. It's just massive.
And it gets worse. Within those thousands of lines, the code was nested 12 levels deep. That means you have an if statement inside another if statement, inside a loop, inside another if, 12 times. It's a logical labyrinth that is pretty much impossible for a human brain to track.
Which brings us to this number, 486. That's the number of unique paths or different decision branches that the code could take through this one function. And this number has a name. It's a measure of pure, unadulterated complexity.
So what on earth does a complexity score of 486 actually mean? Well, to get that, we need to quickly talk about a key concept in software engineering, and it's called cyclomatic complexity. Put simply, it's just a way to measure how many different routes your code can take from start to finish. The higher that number is, the more tangled the logic gets, and the more dark corners there are for bugs to hide. I mean, a good, clean function might have a complexity of, say, 5 or 10. 486 is just off the charts. Here's a good way to think about it. A low-complexity function is like a single, straight road. It's simple, easy to understand, easy to test. High complexity, like our print.ts function, is a tangled spaghetti junction of highways. It is confusing, it's impossible to test every single possible route, and it's a perfect breeding ground for critical security flaws. And if you try to visualize that nesting, well, it's a nightmare. You're trying to follow along. Okay, if this thing happens, then for each of these things, if that other thing is true, and you just keep going deeper and deeper 12 times. The code becomes completely unreadable for a human being. You just can't reason about what it's going to do.
So here's the most important point. This isn't just about messy code or some academic debate. This extreme complexity had a direct, real-world consequence, a major security vulnerability.
There's a golden rule in software design called the single responsibility principle. Basically, a function should be like a good tool. It does one thing, and it does it well. The print.ts function, it was like a chaotic Swiss Army knife trying to do everything. It was handling security, the user interface, networking, file management, you name it. It was a ticking time bomb.
And here is how that bomb went off. The system had security rules to block dangerous commands. But because the code was so complicated, someone added a little performance fix that stopped analyzing commands after 50 steps. Well, attackers figured out that if they just created a command with 51 steps, it would bypass all the security checks, and that could let them steal SSH keys, AWS credentials, and other secrets right off a developer's computer.
Okay, so beyond all the technical drama, this leak gives us this really fascinating glimpse into the reality of building these incredible AI tools. It kind of pulls back the curtain on the messy human process behind the polished, futuristic product. Right? We have this image of AI as this perfect, almost alien intelligence. But the reality, as this leak shows us, is that it's all built on a foundation of code that is sometimes rushed, sometimes way too complex, and always fundamentally written by humans.
And there were other little gems found in the code. Things like an undercover mode to help the AI hide its tracks when contributing to open source projects, a frustration detector that basically just looked for angry keywords, and even poison pills, fake tools mentioned in the code just to throw off any competitors trying to copy them. It's such a revealing look into the strategic and sometimes kind of weird world of AI development.
You know, this whole affair leaves us with a really big question. That print.ts function was a mess created by humans, probably under a lot of pressure. But as AI starts to write more and more of our code, who or what is going to be responsible for making sure it doesn't create its own spaghetti junctions? Who's going to make sure the next generation of code is clean, secure, and understandable? That's something we're all going to have to figure out.